All right. Hello, everyone. My name is Timothy Lee Grant, and today we are going to continue going on our Leetcode journey. So let's get right into it. Let me minimize myself here, and let's start. Okay. Products of array except self. Okay. Given an integer array nums, return an array output where output of I is the product of all elements of nums except nums of I. Okay. So I'm given what? I'm given just Oh, I see. Okay, so I'm given nums, which is an array. Okay? Kind of like this right here. And now I need to output an array of the same size where each element in that array, so you see there's one element, two, three, four elements in the input, and now the output also needs to be four elements. One, two, three, four, okay? Now, each element consists of the product of all of the elements in the input except the ith element. So this is the 0th element. So I want to take the product of not this one, but 2 times 4 times 6. Okay? Now the second element, so the 1th element, I want to product this one times this one times this one, but leave out this 1th element. Okay, so I'm thinking of pitfalls. If there's a 0, if one of these elements in the input is a 0, that's going to throw things off a little bit because anything times 0 is going to be 0. And then we're going to keep going until we hit that 0. And then everything else is going to count all of a sudden. So it's going to be 0, 0, 0, 0. Product of everything, 0, 0, 0, 0. Okay. Can I do something with like where I pass through everything? So I do 1 times 2 times 4 times 6. Okay, so I productize the entire input array. And then I just take the... So like for the 1th element, I would take the product of this entire input array and divide it by 1, because the opposite of multiplication is division. I think that might work, but again, I'm going to have to do something with that 0. How to go about that? Okay, let me just try to start writing that algorithm and then see. Is it, before I just immediately jump into that, let me think if I can come up with any other algorithm that uses, let's see, array, 2 pointers. What other algorithm can I use? Does a dictionary help me at all here? Key value. What would be the key? Is the index? value is the multiple. I can't think of how a hash table would help me here. Oh, and I see that it says follow-up. Could you solve it in O of n time without using the division operator? But that's a follow-up, so I don't care about that. Which indicates that I'm on the right path, actually. So let's do it. Let's do it. Turn the brightness up a little bit, and then, so what do we want to do? So product equals 1 for element in nums, product times equals element. So we're going to multiply each element by that. Okay. Now, 1, 0 equals false. 2, 0 equals false. So what I'm thinking about doing here is I'm creating two flags. If there's 1, 0 in the input, then what I'm gonna, let's pretend, for example, I have nums here. Okay. So I have nums here, and let's say that there's just 1, 0. Okay. So what I'm going to do is I'm going to come here and I'm going to multiply product by 1. Okay, so I get 1. And then I'm going to multiply product by 2, so I get 2. Then I'm going to multiply product by 4, so I get 8. Okay. Then I'm going to come and I'm going to take a note that this is a 0. Okay. And I am going to put that in my flag as I have 1, 0. Okay. And I'm not going to multiply my product by this 0 because that's going to mess everything up. So I'm just going to leave it alone. Then I'm going to come here to this 6 and I'm going to multiply my product by 6. And then I'm going to have, I think it's right here, 48 as my product. Then what I'm going to do is I am going to take note that this 1, 0 is set to true. And I am going to loop through my output array and put a 0 every single spot except where the 0 actually lives. Now, what happens if there's 2 zeros? Well, if there's 2 zeros, like if it's 2 zeros right here, what's going to happen is everywhere is going to be a 0. So I'm just going to put an output with all zeros. So let's start writing that. So if element is not equal to 0, then we want to do this. Okay. If elif, let's see. 1, 0. So else if 1, 0 is, if not 1, 0. So if this is false, that means that so far I have not found a 0 yet. But I just found 1, right? So I just found a 0 and I haven't already found 1. So now I'm just going to set this 1, 0, 0 to be true, okay? Then, so if this didn't hit, then I've already found 1, 0. So I need to set, I just found a 0 and I've already found another 0. So I need to set 2 zeros. So else 2, 0 equals true, okay? So now what we're going to do is we are going to loop through nums, or loop through an array. We're going to create an array. So result is equal to empty array for I in range length of nums. Okay. Now, if 2, 0, so if we found 2 zeros, result dot append, and I want to append the integer 0. Okay. If 1, 0, if we found 1, 0, then what do we want to do? We want to put a 0 in all elements except the element where in our input we found a 0, right? Because, for example, here, okay, in the second element, we actually need to multiply -1 times 1 times 2 times 3, and that's going to be 6. So we put it there in that specific location. So I need to do an if, if nums of I, which is the place, is equal to 0, we need to result dot append product, okay, else result dot append 0. Okay, now else, so this one is saying, well, I didn't find 2 zeros and I didn't find 1 0, so there's no zeros. Else, we are going to take that result and append the product divided by the current element that we're at. So nums of I. Okay? Then I think we can just return result. Let's see if this works. People have been commenting on my videos that I need to press run before I press submit. I get that satisfaction when I press submit and I see accepted. It's psychological. It's like, yeah. But okay, fine. I'll push run. Here we go. Come on. No. Okay, well, I didn't get a syntax error, so I actually do want to submit it just for like record keeping. Okay. But anyways, so wrong answer. Now let's actually look at what was going on. Okay, it's these are float values. So I want to attach an int. The int value here. Does that work? Both were accepted. Let's see. Come on. Bam! There we go. Okay. Wow, that was fun. Awesome. Let's go and look at the solution that he wrote and see if we can learn something, because they said, like, can you do it in O of n time without using the division operator? By the way, what's the time complexity of this? So we do one for loop here, which is O of n, and nothing in here is, everything in there is like O of 1. So then we do one for loop here, which is O of n, okay? And nothing in there is over O of 1. So overall, this algorithm is time complexity of O of n. There we go. Okay. And what would memory space or memory complexity be? I'm building an output which scales in relationship to the input. So that's also O of n. Okay. So let's come here and let's look at the answers. Okay, so what's this? Brute force is, so we're creating a result which is of length n, okay, all filled with zeros for I in range n, so we're going to loop through the array, and then product equals 1 for j in range n, so we're going to loop through the array again. So for each element, we're going to loop through all of the elements, then we're going to move to the next element and loop through all of the elements again, okay? And then we check, like, it does I equal j, and in this case, we don't do anything, we just continue. Else, we multiply the product together. And once we have done one pass, we put that in the ith place as the product and start over, move to the next element, and then return that. Okay, cool. So yeah, that is of n squared. And then for space complexity, yeah, so the output array is of n, is like what I was saying. Now, division, this is the method that I was doing. Okay, so product 0 count. So he only has one, oh, I see. So 0 count is not going to be a flag. It's going to be 0, 1, or 2. If it correlates to the way that I was doing things. Let's see. So for num in nums, if num, then we multiply, else we increase the count of 0. So almost identical to what we were doing here. But he didn't deal with like 1, 0 or 2, 0. He just said like, hey, if it's a 0, I just increase the count of 0, which is a much better solution. Like, it's just more simple, it's more clean, it's nicer. So okay, then if 0 count is higher than 1, we just return all zeros. Yep, that makes sense. That's exactly what I did too. Result is equal to, so he's going to create a result array where we have zeros in everything, and it is in elements long. Awesome. So for I and C in enumerate, so we're going to get the number and the index from nums. So index is here, number is here. Okay. If 0 count, so if there is a 0, result of I equals 0 if C, else product. Okay, so I understand what we're trying to do here, but the syntax is a little bit more compact than what I'm used to. Okay, so if there is a 0 which exists in our array, then the result of I is equal to 0 on the condition that C exists, right? So C is the actual value, okay? Yeah. Otherwise, if C is a 0, then we know that we found our 1, 0 because we've already returned if we have more than 1, 0. Okay, so in that case, we can just put in the product. And we don't need to divide by anything because you can't divide by 0. Okay, so else, the result of I is equal to product, integer division, C, and then we would just return that result. Awesome. Okay, so that's what we got, and let's make sure that I was correct. Yep, O of n time complexity and O of n space complexity. Great. Oh, wow. Okay, so there's a lot of... So prefix and suffix. Okay, what's happening here? So we have n, which is the length, so we're creating a result, prefix, and suffix. All of them have n elements, and 0 is stored in them. Okay. Prefix of 0 equals suffix n minus 1 equals 1. Okay. For I in range, so we're starting at 1 and then going to n. We're doing something with prefix, which is we're taking nums of the previous one and multiplying it by prefix of -1, okay? For range in n minus 2, so we're starting at the second to last and going to 0 and decrementing 1 time. We take the suffix and it's equal to that, okay? Result equals okay, I think I see what's going on here. So I'm creating 3 arrays, but the 2 arrays of interest are prefix and suffix. And the way that I'm constructing them is prefix is I'm multiplying everything that came before it. So I'm multiplying everything that came before it, not including that element. And I do that all the way over. Then I create suffix, and it's everything that comes before it. Or sorry, this prefix is before it. Suffix is everything that came after it. So starting from the back, multiplying everything, multiply, all of those, like that. Okay, then what I can do is for result, I can say, okay, here I am right here. I multiply all of my prefix, everything that came before me and everything that came after me. And then what I can do is that is everything except me, which is what the question is asking. So, okay, there we go. Pretty clever, actually. Now, this one is prefix and suffix optimal, which has the same time complexity and space complexity. So why is this one optimal and the other one is not? Okay. I guess we're just not creating more arrays. So result. So we're creating an array called result, which is filled with ones, and there's n elements, okay? Prefix is equal to 1 for I in range nums, so we're looping through each element in nums. I take the result and it equals prefix, and then I'm changing prefix to be equal to the product So then I'm just updating prefix to be a rolling multiple of whatever it is, right? Then I take postfix, okay, so that's going to be the opposite way, I'm guessing. For I in range length, so starting at the last element, going to 0, so this is non-inclusive stop, decrementing by 1, I'm taking the result and I'm multiplying it by the postfix, which, starting at the very back, right, it's going to be 1 right here, 'cause there's nothing before it, so we just don't want to change anything. The 1 operator in multiplication is essentially do nothing. Okay, and then I just add, or I just multiply postfix, so it's kind of like that rolling multiplication backwards. Okay, so clever. These are clever solutions to it. So I'm glad that we took a gander at this new method of solving this question. That was a quite interesting solution that they came up with without using the division operator. So, great. I hope you guys enjoyed this video. If you did, subscribe. I'm going to be making more of these Leetcode, neat code videos. My goal is I'm just going to keep going, and I want to do the entire roadmap. So I want to do everything here. And then also I do videos on, right now I'm doing this project right here, which is trying to learn how to become a back-end software engineer. So trying to do projects to help reinforce the skills that I need for software engineering, to become a software engineer. So if that sounds interesting, subscribe. I would love to have you around. I hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you guys soon.